Hello my dear students, welcome to my YouTube channel that's Concepts of Chemistry. So before starting today's lecture, please do subscribe my channel. So my dear students, today we are going to study the effective radius of nucleus. As we know that protons are concentrated at heavy center called nucleus, due to which nucleus will generate its own nuclear field around nucleus which is positively charged. So Rutherford considered the radius of nucleus up to the nuclear field and termed it as effective radius of nucleus. So that's the introduction for today. Let me write this thing. As we know that all protons of the atom are concentrated at heavy center called nucleus, due to which nucleus will generate its own nuclear field around itself, which is positively charged. So Rutherford considered the radius of nucleus up to that nuclear field. So in the previous lectures we have learned about the alpha ray scattering experiment and the potential energy. We are going to apply that concept in finding the effective radius of nucleus. So what we are going to do in this experiment? We are going to accelerate alpha particle towards the nucleus, and we'll study about that distance, and will more appropriately we will evaluate the distance of the point from nucleus from where alpha particle deflected. So let's start the diagram. So first of all, I'm mentioning the nucleus. Assume this is my nucleus. In the nucleus, how many protons are there? That is the atomic number. And what's the charge of one proton? It's E. So this is plus Ze, because the charge on proton is positive. So let it write complete, plus Ze. Z is the number of proton, E is the charge on proton. Positive signifies it's a positive charge of proton, obviously. So let me mention, this is the point A where we have taken the alpha particle, from where alpha particle got accelerated. Now this accelerated alpha particle is moving towards the nucleus in this direction. It is moving towards the nucleus, is approaching the nucleus, is getting slowed down, now it's approaching the nucleus. From this point, the alpha particle got deflected from its original path. So let us mention this point to be B. This is my point B. So what will be my motive? I have to evaluate the distance of point B from the center of nucleus, and that will be my effective radius of the nucleus. So now let's evaluate it. Now let us talk about the term kinetic energy and the potential energy. Now listen to it very carefully. At the point A, kinetic energy, I'm writing complete, kinetic energy of alpha particle is maximum. Now as the alpha particle approaches the nucleus, its kinetic energy goes on decreasing and potential energy goes on increasing. Now when the alpha particle approaches the point B, here at point B, the alpha particle will stop for the fraction of second. When the alpha particle stops for the fraction of second, its kinetic energy becomes 0 and its potential energy will be maximum over here. Now from point B, this alpha particle will be deflected. So now why at point B potential energy of the alpha particle is maximum? Because we know that alpha particle is helium dipositive ion. When this helium dipositive ion approaches the point B, there will be the repulsive forces between the positive charge of the nucleus and positive charge of the alpha particle to be the maximum. That's why for the fraction of second, alpha particle will stop at point B and will get deflected along the path C. So now let us evaluate the different kinetic energies and the potential energies over here. Now let's talk about the kinetic energy at point A first. Now I'm writing kinetic energy. What's the formula of kinetic energy? Is half mv square. Now what's the m? M is mass of alpha particle. We have evaluated the mass of alpha particle in the previous lectures. That was 4 AMU. The helium dipositive ion has the 4 mass number. It comes out to be 4 AMU. That is 4 into 1.66 into 10 raised to the power minus 27 kilograms. And what's the V? V is the velocity. V is the velocity by which alpha particle by which alpha particle is accelerated towards nucleus. So that was about the point A. Now let's talk about the point B. At point B, our potential energy is maximum. In just the previous lecture, we have studied about the formula of potential energy. The potential energy is K into Q1 into Q2 divided by small r. Now, was the charge 1, the Q1 over here? Obviously, it's the alpha particle. I am considering my alpha particle to be the charge Q1. So, what's the value of Q1? The charge on alpha particle, that is helium, it's a di-positive ion, so it's plus 2 E. What's the value of E? It's 1.6 into 10 raised to the minus 19 coulombs. Now, let's talk about the charge 2. It's Q2. Obviously, it's the nucleus. It's nucleus, Q2. Now, what's the charge on nucleus? How many protons are there? That is the atomic number, Z. And what's the charge on one proton? It's plus E. I'm taking plus in the front. So Q2 comes out to be plus Zd. Now let's put this thing in the potential energy. Now, potential energy comes out to be K. What's the charge Q1? It's alpha particle. It's plus 2 E. What's the charge Q2? Is the nucleus. It's plus Ze divided by small r. So potential energy comes out to be 2 into K Z E square divided by small r. So that's my potential energy. So I have got my kinetic energy, that's half mv square, and I have got my potential energy, that's kz e square divided by small r. So now let's talk about radius of the effective radius of the nucleus. Now I have to evaluate this radius. That is my motive in this lecture. I have to find out the effective radius of the nucleus. Now, as we all know that energy can neither be created nor destroyed. I am writing energy can neither be created nor destroyed. Although it can be converted from one form to another. So what's happening in this case? As the alpha particle approaches, I'm writing as alpha particle approaches nucleus, its potential energy increase, its potential energy increase at the cost of kinetic energy, but as energy can neither be created nor destroyed, due to which the total energy of alpha particle will remain constant. So what will happen over here? These lines proves that kinetic energy of alpha particle A will be equal to the potential energy of alpha particle at B. Now let's come back to the diagram. At point A, the kinetic energy of alpha particle is maximum. That means here potential energy is 0. Now let's talk about the point B. At point B, kinetic energy is 0, but potential energy is maximum. So now let's put the value. The kinetic energy of alpha particle at point A is half mv square. Now potential energy of alpha particle at point B, it is we have just calculated 2 kz square divided by r. So I am writing 2 kz e square divided by small r, and here this small r is the effective radius of nucleus. So I have to evaluate that. My small r, the effective radius of nucleus comes out to be 4 kz e square divided by mv square. So that comes out to be the effective radius of nucleus. Now just carefully examine this formula. Here this k, this e, and the m. Here k, z, here k, e, and the m are constant values. These are constant values. That means the radius of nucleus will be directly proportional to the atomic number and will be inversely proportional to the velocity of the alpha particle. So it proves that if z, that is atomic number, if atomic number is more, then more protons will be there. So more will be the effective radius of nucleus. Now let's talk about the velocity of alpha particle. If velocity of alpha particle is more, if velocity of alpha particle is more, it's the inverse proportionality. If the velocity of alpha particle is more, then that alpha particle will approach more closer to the nucleus, and hence the radius of effective radius of the nucleus will decrease. So if the velocity of alpha particle is more, it will approach more closer to the nucleus, and hence effective radius of nucleus will decrease. So if alpha particle is more, then alpha particle will approach more closer to the nucleus, and hence effective radius of nucleus will decrease. Because the effective radius of nucleus is directly proportional to the atomic number and inversely proportional to the velocity of alpha particle by which that alpha particle is projected towards the nucleus. The more the velocity, the alpha particle will approach more closer to the nucleus, and hence the effective radius of nucleus will decrease. So that was my topic, in which I have finally found the formula for the effective radius of nucleus, which comes out to be smaller. The effective radius of nucleus comes out to be 4k z e square divided by m v square, where k is constant of permittivity, where the k is a constant of permittivity of medium now z is the atomic number. What's the e is the charge of the proton. M is the mass of alpha particle. E is the charge of proton, also the charge of alpha particle. As both the quantities are same, so that's why we have taken the word small e. And what's the v? V is the velocity of alpha particle with which it is projected towards nucleus. So that was the topic for today. We have just evaluated the effective radius of nucleus. I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear his or her doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please like, subscribe and share my channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.